Writing chemical equations. So a chemical equation is a short, concise description of a chemical reaction. So we use formulas and symbols. Here's an example. A, and then in parentheses, AQ plus B goes to C plus D. There's several things to explain in here. Here we have an arrow. It's a little bit like a math equation, A plus B equals C plus D. But instead of an equal sign, we have an arrow because chemical reactions usually go in a particular direction. So this is telling us that if we mix A and B, it will form C and D. It will produce C and D. So on the left side, these are the reactants. They react to produce the products. So the products are over on the right side. We need to be able to identify the reactants and the products. The reactants react to produce the products. In parentheses, these are called state symbols, and they're giving the physical state of the elements or compounds in the reaction. I think we've seen these before. AQ stands for aqueous, meaning it's dissolved in water. G is for gas. S is for solid, and L is for liquid. It's not shown there. We do not always indicate the states. The way I run my classes is if the question says to include state symbols, you better include the state symbols. If it doesn't specify, then I'm okay with you leaving them out. Because sometimes we need to know them and other times we don't. So I don't get too hung up on that. Sometimes we have a catalyst in the reaction. A catalyst is something that just speeds up the reaction, but it doesn't actually get consumed. So if we had a catalyst, we would write the catalyst above the arrow. Sometimes you'll see things written above or below the arrow. And those are not actually reactants or products. So, I got ahead of myself, as usual. Solid, liquid, gas, aqueous. Sometimes we mix two things together and nothing happens other than physical mixing. And so, bless you, we abbreviate that NR for no reaction. The arrow indicates, these things produce or yield or give. It's just used to separate the reactants from the products. We use plus symbols between reactants and between products. The little delta symbol, that means, hello.
Can you stop and talk to me when you're done?
Yes. It's just the dean. She wants to talk to me. Yeah, I'll come talk to you. Sure. Anything you want. The little triangle. Triangle is the Greek letter delta. It usually means change. Here, when it's over an arrow, it means that heat is a catalyst for the reaction. It means you have to heat this. And the way I remember that is, doesn't that look a little bit like a campfire? Just a little bit. It reminds me of a campfire. Or maybe it reminds you of a tent. And what's the point in camping if you can't have a campfire, right? So however you remember that. Here's an example of a catalyst written above the line. Here, Fe, iron, is necessary as a catalyst. We talked about the 7 diatomic elements, didn't we? Did we? Horses need oats for clear brown eyes? Okay. Yeah, some of you are mentally on spring break, and I feel for you. But, yeah, we did talk about that. When we're writing chemical reactions, chemical equations, that's where remembering the 7 diatomic elements is really important. Because if oxygen is a reactant or product, the formula is O2, not just O. And that'll mess things up if you do that part wrong. So remember these guys. So let's do some examples. We also need our nomenclature skills in doing some of these problems. So here we're going to write chemical equations for the following chemical reactions. If you've had chemistry before, we're not going to worry about balancing or anything here. We're just going to write down the reactants and products. So mercury liquid and fluorine gas react to give solid mercury 2 fluoride. They're going out of their way to give us the states, and so we're going to practice writing them down. What's the symbol for mercury? Hg. So Hg, and it says it's a liquid. So in parentheses, I always use a script L for my lowercase l's because otherwise it can look like other things. And fluorine gas. What's the symbol for fluorine? F. Is fluorine a diatomic element? Yes, it is. So it's F2. And then gas. And here it says to give. That's your signal that here's the arrow coming in. So the mercury and the fluorine produce solid mercury 2 fluoride. Well, it's a solid. What's the formula? We have to think about our charges. This is an ionic compound, right? Mercury 2 fluoride. Mercury 2 means the charge is 2 plus. What's the charge on a fluoride ion? -1. So, I think somebody said this earlier, HgF2. It's really important to get the formulas correct. Zinc metal reacts with sulfuric acid to give aqueous zinc sulfate and hydrogen gas. Well, how would we indicate zinc metal? Zn. It didn't give us the state. What if I said you have to write the state symbols?
It says metal, so it's solid.
Yeah, it says metal, so it's probably a solid, right? Ooh, I almost wrote M for metal. Why was mercury a liquid, though? Isn't mercury a metal?
But at room temperature.
Mercury is a liquid at room temperature. I keep looking at that periodic table. I don't like that one. Look at this one. You see mercury on there? Its letters are in blue. It's a liquid at room temperature. There's only 2 elements that are liquids at room temperature. So the periodic table can help you. And sometimes we need a little common sense. Sulfuric acid. Close. H2SO4. Sulfuric comes from sulfate. Sulfate ion, SO4, 2 minus. And so sulfuric acid has 2 hydrogens, and then that sulfate ion. What's the state symbol for an acid? Aqueous. So when we talked about acids, we talked that all the acids are dissolved in water, they're aqueous. Now it says to give aqueous zinc sulfate. Well, zinc sulfate is an ionic compound. I'm kind of rushing through this because this is not the point of this lecture. Zinc is a 2 plus ion. Sulfate is a 2 minus ion. So we push them together, we get zinc sulfate, and it's aqueous. And hydrogen gas, how do I write that? Yep, plus H2, and it's a gas. Well, there we go. Any questions? You need to learn your nomenclature, but if you're still rusty on that, go ahead and look stuff up. You obviously can't use Google on an exam, but on your homework, if you're doing a problem like this, try to get the formula without using Google, and then use Google to check and make sure that you got it correct. Because if you don't get the formulas correct, you're going to have loads of problems. Acetic acid. What ion does that come from? Not nitrate. Acetic. Rick ate him before he could bite us. So acetic comes from acetate, acetate. Okay, acetate is C2H2, H3O2 with a -1 charge. Like, oh, wow, yeah, well, you've got all of spring break to work on that. C2H3O2. So there's acetic acid, reacts with plus aqueous potassium hydroxide. What's the formula for potassium hydroxide? KOH. Potassium is a +1 ion, hydroxide is a -1 ion, and so we just need one of each, aqueous. Oops, I don't want to do plus there. To form, to give, arrow, aqueous potassium acetate. So C2H3O2 is acetate, and it's potassium acetate, so we just need one of the potassiums. It says that's aqueous plus water. What's the formula for water? H2O. What's the state of water? Depends on the temperature, doesn't it? If a temperature isn't specified, then we assume room temperature. So at room temperature, water's a liquid. Got the basic idea of writing equations?
What's the difference between aqueous and liquid?
That's a good question. What's the difference between aqueous and liquid? A liquid is a pure substance. So water is a liquid. All of the particles in water are water molecules. There are not a lot of compounds that we encounter that are liquids. We encounter a lot of aqueous solutions. If you put salt or sugar in the water, it's an aqueous solution. Things like ethyl alcohol would be a liquid, but an alcoholic beverage is going to be a mixture of alcohol and water. And so we wouldn't write the ethanol as a liquid. So we actually see liquid as a physical state fairly rarely. Things are not often liquids. We see a lot of solids and gases and aqueous. Very good question.